So, good day, everyone. Good day, ma'am. For today, I'll be sharing and discussing to you the technique of integration, which is the integration by parts. So before we proceed and dive into our function, let me first share to you the formula of integration by parts. So we now have here the integration of u dv equals uv minus the integration of v du, with u equals a function of u of x, dv is a variable dv, v is a function of vx, and du is a variable of du. So these are the specific steps in solving the integration by parts. First, we need to choose or identify the u and v. Next is differentiate the u, which is in this form right here. And then the next step is to integrate v, which is in this form. Put u where with this formula, u is integral of v dx minus the integral of u and the integral of v dx dx. And finally, simplify and solve. So we now have here the function, the integral of x squared sine x dx. With our formula here, let's first identify the values of u, dv, v, and du. So from our function, we choose our u as the x squared here, and then the derivative of x squared, which is we put in the value of the du, is equal to 2x dx, and then our dv here is sine x dx, which is its integral is negative cosine x. So we will now substitute its values, and we derive from this equation. So the u here equals x squared. So we now have here the x squared, and then the v is negative cosine x minus, so we have here the minus sign, the integral of v, which is negative cosine x, and du times du, which is 2x dx. So to simplify, we derive this equation, which is negative x squared. From this, we multiply x squared times negative cosine x, which is negative x squared cosine x. And then we place the number 2 here, and then the x will remain in the function. So negative times negative equals positive. So that becomes 2 the integral of x cosine x dx. So before we proceed, we need to first integrate the second function. So we will use another page for that. We will solve the integral of x cosine x dx. Again, using our formula, we need to identify the values, the values of our variables here. So let u be the x here, and then its derivative, which is simply 1 dx, and then our dv here is cosine x dx, and its integral is sine x, sine x. So let's substitute its values. So the value of u is simply x, so we put x here, and then v is sine x minus the integral of v, which we have the sine x, and du du is dx. We now have here, yeah, this one. Sine x du, yeah, 1 here dx. So we have here the v, which is sine x, and then du. This one is just simply 1 dx, or we can simply just put dx. So to simplify, we now have here, so the integral of sine x is negative cosine x. And to simplify, the integral of x cosine x dx equals x sine x plus, so we multiply negative with another negative here, so that becomes positive. So our final, the answer, the integral of x cosine x dx equals x sine x plus cosine x plus c. So we will go back to our solution. So we will now replace this with what we have just solved earlier. So that becomes negative x, just copy negative x cosine x plus 2. And then we replace this with its integral, which is x sine x plus cosine x plus c. And then simplify by multiplying the value of 2 to each function. To each term. So we just copy the negative x squared cosine x plus, so 2 times x is 2x sine x, yeah, 2 times x sine x is 2x sine x plus 2 cosine x plus c. So we don't need to multiply 2 with the c because this is a constant variable. So we now have our final answer here. Therefore, the integral of x squared sine x dx is negative x squared cosine x plus 2x sine x plus 2 cosine x plus c, using the equation, or the integration by parts. So again, just a review, the formula of integrating using the integration by parts is integral of u dv equals uv minus the integral of v du, which we have its values, which is u is equal to the function of q of x, dv is a variable dv, v is a function of v of x, and then du is a variable du. So these are, again, the specific steps that you can read and follow in solving the integration by parts. So choose u and v, differentiate u, integrate v, put or just simply substitute its values to the function, and then simplify and solve. So again, that is the integration by parts. This is Tricia M. Guimarangan, and thank you for watching.